Okay, folks, we're going to get started. My name is Joe Gallo, and I got Sagar Patil here, corrosion engineer for Cathodic Solutions. I'm the owner of Cathodic Solutions, corrosion technologist, CIP level 3, corrosion inspector, and I've attended internal for pipelines for internal corrosion for NACE. So we're going to get started with Sagar Patil giving you facts and figures as far as PHMSA. What we found there as far as amounts of internal corrosion fatalities and maybe just incidents. And Sagar's real good at that. He'll go over that, and then I'll take it over with case studies, telling you more about the Excalibur Shield we're going to present to you today. But without further ado, I would like to put you Sagar Patil.
Hi everyone, good morning. Today we will be speaking briefly about internal corrosion and associated compliance requirements. Then we will be presenting Excalibur Shield as a vital part of your ICMS, that is Internal Corrosion Management System. We will be demonstrating its advantages, application and results, its components, and finally with supporting case studies. We utilize pipeline as a mode of transportation for important commodities such as crude oil and gas. However, with these important commodities, corrosive materials like hydrogen sulfide, carbon dioxide, and bacteria get entered in the stream. These corrosive materials can lead to microbial-induced corrosion or electrochemical reaction at the surface of the pipeline. This process finally leads to a corroded pipeline, which is known as an internal corrosion. This situation can arise if we don't perform proper chemical inhibition or timely pigging operation. The table over here is statistics on corrosion-related reported incidents over the past 20 years. This data was obtained from PHMSA. If we look at the sixth column, it shows us the cost due to internal corrosion. If we compare these costs to the total cost of the overall corrosion, it varies from 6 to 80%, with an increasing trend observed over the past 20 years. The total cost to the industry due to corrosion is 11%. Of this, 49% is due to internal corrosion. One such incident took place on 12th of December 2016 in Potter County, Pennsylvania, where a 20-inch carbon steel pipeline of Transcontinental Gas Pipeline Company ruptured and caught fire. Fortunately, there were no fatalities or injuries. However, this incident cost the company $66 million and 2 years of downtime. Internal corrosion can have serious consequences. These include fatalities and injuries, damage to environment, loss of commodities and natural resources, and heavy fines imposed on our company. So what can we do to prevent such disastrous incidents from happening? We can utilize new technology available to us to collect data, and from this data, we can analyze and come up with mitigative measures to prevent it from happening. One such new technology available to us is Excalibur Shield. By making Excalibur Shield a part of your internal corrosion management system, you can methodically characterize the threats posing to your pipeline. This means identifying the kind of corrosive atmosphere that is present within the pipeline and managing mitigative steps to prevent it. It can also help apply prevention and mitigation measures such as targeted chemical treatment by using just enough amount of chemicals, corrosive inhibitors and biocides within the pipeline to reduce the corrosive atmosphere. Finally, Excalibur Shield can also help check the effectiveness of these chemical treatments. It is very easy to use Excalibur Shield. You don't need a specialized retrieval tool to access it. You don't need any heavy equipment to operate it, so there's no risk of injury and hazard. It reduces the operation time and risk of exposure by using a simplified sample collection technique. Excalibur Shield is very flexible to use. You can customize it to your own needs. You can customize its metallurgy from steel and various other alloys as per your requirements. It is very compact and it fits within a 13-inch of clearance. It can be easily installed on above ground pipeline risers and pig receivers. Along with all these advantages, Excalibur Shield has delivered impressive results. These include solid and liquid sampling that leads to reliable microbial induced corrosion analysis, coupon monitoring for metal loss per year, planktonic and sessile bacteria monitoring, residual monitoring of corrosion inhibitor. In summary, Excalibur Shield helps in chemical treatment optimization, thus leading to increased asset longevity and its operation. Excalibur Shield helps monitor the corrosive materials that are present within your pipeline, the extent of microbial induced corrosion and electrochemical reactions. Once we have data on these, we can take proper actions, that is targeted chemical treatment and timely pegging operations to bring about effective pipeline transportation. With that, we can transport our important commodities from source to gathering stations, separators, to the refineries, and finally as refined products to our markets. Excalibur Shield can help assist our chemical companies and operators to increase the assets longevity. Now Joe will elaborate more on Excalibur Shield, its components, and show how it helps you meet the compliance requirements set forth by FEMSA, and finally present with supporting case studies. Thank you.
Thank you, Sagar. But anyway, at any time you have any questions, just stop us. We'll try to answer to the best of our ability. But just like Sagar was saying, these case studies coming up, compliance, NACE as well. So we'll start with NACE, standard practice for NACE, talking about where to place coupons. So according to NACE, they want us to install these coupons at a represented location. What I interpret that to be is to be in a representative flow location and the most severe respect for corrosion. So it all going to depend on your viscosities, your flow regimes, your MPYs, your corrosivity, as far as where to put your most severe case with corrosion. So if you got oxygen in your line, oxygen rises, you need something on top of the line, right? If you got a water cellulite in your lines, something at worst case scenario at the bottom. So not any one is going to do, but you need various types to capture these two, a representative location and the worst case for corrosion. So NACE again, standard practice for NACE, talking about how often should we read these coupons. How often, according to your viscosities, your corrosion rates, and of course, how much product you flown through your line, and 2 times a year. That's the minimum. If you're having problems, you need to read these coupons more often. So at a minimum, 2 times a year, not to exceed 7 times a year. International standard. FEMSA. The operator responsibilities is to investigate any internal corrosion that's happening inside your pipelines. So you need to check out elevation low points, water sellout points, water inside your pipeline, your coupons, microbial induced corrosion, MIC, somebody called it MIC. Maintenance pigging program, maintenance pigging. If you don't have any monitoring equipment, you can go with your maintenance pigging group, capture any water solids from your maintenance pigging and capture data there. And also the operators should study solids and liquids and get with your experts, chemical group, operations group, come up with a plan to mitigate your atmosphere, corrosive atmosphere, and make less of. So we're going to find out how much of these line items the Excalibur Shield can help you with. Each one of these line items, the Excalibur Shield can help you out. So there's a first view of the Excalibur Shield. It's a little 7-inch device. These 6 line items, it can help you out with low points in the line. So your pipeline is going straight on a geographical area, and it drops below an interstate. It drops below another pipeline crossing. You're addressing your elevation low points. You're addressing your water out, the water cell out. This is a 100 mil cavity. You can collect waters or fluids, whatever's in your pipeline, and study those fluids, see what's going on with the fluids. Coupons, you can install up to 4 different coupons on this, inside this internal corrosion device, 1 at the mouth and 3 inside the cavity, the 100 mil cavity. Microbial induced corrosion, MIC, you can study your sessile bacteria, sessile, slime, biofilms, and see what your mix is doing or not doing. Maintenance pigging program, if you see a lot of solids coming into this device, it's time to get with your operations and say, hey, we need to either run more pigs or run a different style of pig. And that's the pigging program. It can capture the solids and liquids. and make a mitigation plan to reduce the corrosive atmosphere. Here is the Excalibur Shield as we know it today. It's a 7-inch device. It starts off with a mouth with a coupon, 2-inch AMPP threads, octagon shape in the middle for better installation and removal of the Excalibur Shield, 2,000 PSI, 100 mil cavity, and we have specialized equipment where you can install at the mouth of the coupon a disc coupon to study any MIC right here in this area, worst case scenario. You can install up to 3 different devices, 3 different coupons inside this cavity. One for a weight loss coupon, one for a full coverage test, maybe one for oxygen test. We also have this other specialized equipment that if you only have 1-inch infrastructure, we have this 2-inch, 1-inch reducer. You install this, keep on trucking with the Excalibur Shield. And these are available in 2 metallurgies, 360 stainless steel and carbon steel. Carbon steel, we got the outside painted with 100% paint system. The inside is painted with Teflon. The inside is painted with that paint system. Last year we got our patent number issued from the U.S. government, so we were real proud to be intellectual property. What are the solutions here? What do we need to do to make these pipelines to produce less corrosive atmosphere? If you have a pigging program that's only ran half a year or once every month, and you expect to get different results, you are never going to get different results. You need to change it up. If you're using soft foam pigs, this could probably go inside a 1-inch line. They squeeze up. Maybe if you run these type of pigs, maybe it's time to upgrade to a polymer pig. More disc, brushes, maybe a steel mandrel pig. We have more available technology nowadays to come up with different results. The key point here is to be more proactive instead of reactive. Being proactive, maybe looking at your volumetrics. Maybe lines at one time were turbulent flow. I got a little water bottle here, 100 ml bottle. I got 3 phases here. I got water, oil, and oxygen. And if you're turbulent flow, you don't have to worry about anything. Everything's being suspended line, everything's carried out, no worries. But maybe now you're laminar or stagnant. That's where you have to worry. It's better if you have liquids in your lines, waters especially. ICMS meetings, maybe you're only meeting once a year with the group that your operations, your chemical company, your corrosion techs, maybe make it twice a quarter, twice a year to have everybody on the same page as far as come out with a good mitigated plan to make less corrosive atmosphere inside these pipelines. Chemical, folks. Chemical does not work without pigging. It's just like brushing our teeth. We use a toothbrush, toothpaste, and mouthwash to clean our teeth. Same thing with these pipelines. If you use pigging in conjunction with chemical, your chemical costs will go down in some cases, majority of the cases. So you want to combine chemical and a maintenance program to clean out your pipelines and to coat the inside of your pipeline. Chemical chemistries, maybe at one time you were getting full kill on your bug counts, your sessile bacteria, SRBs, APBs, whatever the case may be. Maybe they get immune to these chemicals. Maybe you got to do a kill treatment, change it up to be more proactive. Smart tool. We run these smart tools every so many years. Make sure your smart tool and your chemical program data is saying the same thing. You don't want your smart tool saying we got a bunch of anomalies, and your smart tool data is not showing any anomalies. So marry them up. If you're more proactive, folks, that's the best option. If you're reactive, you're waiting for a leak to happen. I believe everybody in this room has one goal in mind to keep our products inside of our pipelines. So we don't want to be reactive. We want to be proactive. Once you use metal, folks, there's no way of getting it back unless you cut out one section, another section, put a new section. So very important. Okay, moisture. If you remove moisture from these pipelines, basically you'll be fine. Moisture mixes with salts, chlorides, H2S, combined, they make corrosion cells. So I got an example here at the bottom, 8-inch crude oil pipeline operating at 200 barrels per day, 1% BS&W, you have a probability to introduce 200 barrels of water into your pipeline system. If it's less than turbulent, that water's going to settle out to the bottom. Remember we shook it up a while ago? It don't take long for water and oil to separate, and this moisture lodging into between the wells, the grist wells. You mix it with salt waters, they create corrosion cells, right? So if you turbulent flow, like we said, I'm not an engineer, but engineers help me out. I believe turbulent flow is 4 miles an hour or greater, and laminar flow is about 2 miles an hour or less. Laminar, stagnant is where you have to worry about it. Turbulent, you have to worry. Maybe though, my opinion, in turbulent, you have to worry about your bends. Your erosion happening at your bends, turbulent flow. Moisture again, moisture is really important. This little water droplet is all a microorganism needs to survive and live. It lodges into that weir field and settle in and start making corrosion cell. It will reproduce over and over, colonize. The little water droplet is like an ocean of water to these microbes. They lodge in there, they reproduce, and they're having a good time in that water. These little microbes. Remember, these microbes, the only way you can see them is under magnification. That's the only way you can see them. So little water, you don't need much water to start a corrosion cell, to mix with these salts. Okay, now we're going through our case study. We got 3 case studies here. The first one is a 12-mile line, 12 inch and 12 miles long, and this pipeline got into production, and we installed the Excalibur Shield at the same time it got into production. It's a crude line. So over here on this side, it will depict weight loss of your coupon. This side over here is your MPYs, metal loss per year. Bottom is time in 1 month increments, 8-month study. So we have here an incline in corrosivity as far as our coupon is concerned. It's not bad yet. It's under a 1 right here. A 1 is right here. It's not bad yet. 1 is part of from a 1 to a 4.9 is a moderate. So it's not to be concerned yet, but it's increasing. So this 6 month is the picture we saw that we removed fluids from the Excalibur Shield in our coupon. We saw black waters and some little black slime around the coupon, about 0.8 MPY. And then we told them, okay, we feel this. If you don't have a maintenance springing program, it's time to incorporate one, and boom, the corrosivity went down. But the next month after that, they either got more waters, whatever the case, more solids, and this is what we saw at the looks like the 9th month. This picture over here. So we saw more moderate solids. The MPY rates went into about a 1.8 MPY. We need to kick on our key point indicators. KPIs, make less corrosion in the atmosphere on this pipeline. So we told them, hey, we know you have a maintenance springing program, increase it to their monthly, let's go weekly, and let's get that chemical inside line. Look at our decline, exponentially went down. The Excalibur Shield helped this customer keep their pipeline integrity. This next on, we'll be comparing the retrieval style for our Excalibur Shield on this 10-inch condensate line. The flow of this pipeline is that way and this way. This retrieval style was embedded right here. The way this works, this retrieval style is it inserts in from the top of the line, it lowered down to the bottom line. And this is what we see. This photo documentation is telling us the very tip of that coupon is in the worst case scenario. The rest of it is condensate. Basically, condensate is like gasoline. There's boat trucks. You put gasoline, they can go as pristine fluid. But basically, that condensate is an inhibitor, but not for the very tip of that. Look at our MPY. It's a 0.17, not even close to a 1, a moderate. It's a 0.17, 117 days exposure. We told the customer, what do you think if your coupon, instead of being vertically, what if it was laying in the worst case scenario? On a crude line or a wet gas system, from 5 to 7 o'clock, the belly of that line is your worst case scenario with respect to corrosion. So they heard us out. They helped us out by installing these devices. These devices were internally coded. They had them laying around the yard. Within 4 hours, we had these devices installed and ready to install our Excalibur Shield. Within 13 inches, if you have that much of clearance, Excalibur Shield can be installed on one of your pipelines, assets. So we even have a little drain pan to collect any waters or fluids. So now we have availability to monitor our solids, our weight loss, our waters, our fluids, everything. Before, the scenario was that we would schedule a pig run, and we have to wait to pig run and collect any waters or solids from the pig run. So, and then we have something scheduled the day before. Hey, we cannot run a pig because of manpower, because of fluid. We don't have enough fluid around point A to point B. We have to reschedule it. 2 weeks later, they would call me, hey Joe, we're sorry. rend the pig without calling you, but we got your back. We got your waters and solids in a water bottle by the pig trap. The next day I would show up with my water bottle around the pig trap, nowhere to be found. It was over there against the fence line with the rest of the mesquite bushes. So West Texas, you know, this year wind blows a lot, so the bottle was capped off, dehydrated solids and fluids, so there's no reason to take this out, this solids and waters or whatever I have to a laboratory because microbes are probably already dead. They gotta remain in their environment. So there's no sense for me to taking that, but now I got fresh solids, folks. Fresh solids within hours, within a day, I can take these solids to see, okay, are this brown solids part of my pipeline? What kind of mix is this? You can do a slime test, DNA, speciation, fresh solids, fresh waters. Got brownish water here. We can run planktonic, SRB, APPs, inoculate the bottles in the tailgate, wait 14, 28 days, see what the results are, see how severe these planktonic bacteria is. Fresh coupon analysis. So now, our pipeline, our low-lying area, remember, when it drops, that's the way your low-lying area is looking on the pipeline. Where it got a geographical low, it's dropping out, that's the way your pipeline's looking inside. So now, this is a 30-day study. Look at the 1 MPYs, it went up into the moderate phase. I dare to say that if this would have kept 117 days like the other one, it would have probably been way more than in the moderate phase. And here's a shot at the original coupon from the retrieval cell coupon. It's the very tip of the coupon versus the Excalibur Shield, mimicking the low-lying area in your terrain. So now, another 30 days go by, optimization. We have to incorporate more pigging, maintenance pigging, inhibitor, maybe some biocides, 0.08 MPYs. Look at our coupon. So that's how your pipeline's looking at a low-lying area. Any questions up to this point? One last case study. This 8-inch line, 32 miles long. They had sweet oil. From time to time, they had Sagar gas at 1% BTW, operated at 5,000 barrels a day. So that's stagnant flow, laminar flow. And what they're having problems with, at the end of the line, they were stacking these solids. And what the plan was to convert it from a sweet service to a C5 plus gasoline, natural gasoline service. So they were going to address the MPYs, corrosivity, and the solids with the help of these Excalibur Shield. So I have some live data here where they were getting like a 7.5 MPY, and that's saying that it's a severe metal loss. So another 41 days go by. They added this chemical. I'll show you here in the next slide what chemical it was. Added that chemical to reduce the solids, 2.2 MPYs. Here, they got the problem resolved. Here's their chromium treatment. First day, heavy solids. Second day, and so on. 13th day, minimal solids. So the Excalibur Shield helped them with more pig introduction, more the right chemical. They got their MPYs figured out, solids, whatnot. They're trucking along now. They converted their pipeline to this new other product, this natural gasoline. So compliance, what did the Excalibur Shield help these folks at? It helped the operator with elevation low points. Every time the low point on these crude oil lines, the water fall out inside these pipelines, coupons, monitor coupons, your MPYs, your microbes, your solids, microbial-induced corrosion, your mic, maintenance pigging was addressed. More likely than not, in all these cases, we have to increase chemical, increase the maintenance pigging. The operator got the sample, the operator got the sample solids and liquids, make a mitigation point. In all these three instances, it made the atmosphere less corrosive. There's instances out there also where it can go the other way. You're introducing too much chemical, you can save it low, you can adjust your chemical, optimize your chemical, make it less, boom, lower your chemical costs down a little bit more. But in all these scenarios, we got them going the other way. So I got this system, it don't belong to these folks anymore, but it's a crude oil system, it's about 250 miles. These main laterals are probably 20, 30 miles or so. There's the main line going back to the wink area. So everywhere you see a line with an arrow, it's where I would recommend an Excalibur Shield to start understanding your internal corrosion management system for this pipeline. So you want to make sure you have your main lines, your laterals and whatnot especially right here, see where it says trucking. Trucking is, when they say they have bad oil, that means they have a bunch of water. And if you don't have a verbose lackless system, the water bypass. So mainly downstream of that trucking. So just to begin, I will have 10 Excalibur Shields here, and maybe even double once you start understanding what else you need. Maybe triple, but to start understanding what's going on inside your pipelines, 10 to start off on this 250-mile gathering system, crude oil system. So you can find our Excalibur Shields offshore pipelines, onshore pipelines. Here are some of our customers: ConocoPhillips, Enterprise, Plains. The list goes on. It's nice to be here back in West Texas. Thank you for your attentiveness. And if you have any more questions, come up after the meeting, and I'll tell you more about them. And your center of your table, you have some cards. We got a barcode. Screenshot that. It's got a 5-minute video if you'd like to know more about the Excalibur Shield as well. Thank you very much.